Welcome to another exciting week. Before we move into the subject that we're going to be covering this week, I'm going to like us to do some housekeeping. I've noticed that most of us wait to post our discussion board contribution on the last day of the week. It's going to be imperative that you do that latest by Thursday, so that all of us can have adequate time to read through what you've posted and respond accordingly. The purpose of the discussion board is to create an environment for you to ask questions, to contribute, and apply the information that you are learning in the course. So do everything within your power to take advantage of that. Last week, we looked at minerals, and we said minerals are the basic building block of rocks. We learned that a mineral has to be naturally occurring. It needs to have a definite crystal structure, a chemical composition. It has to be solid. This week, we're going to look at igneous rocks. We'll be studying the origin of magma, as well as the differences between volcanic and plutonic igneous rocks. We'll also look at the Bowen's reaction series and explore the relationship between tectonic plates and the locations of igneous rocks. Magma simply means molten rock. When the rock is molten or melted and it is below the surface of the earth, it is called magma. When it comes out on the surface, it is called lava. Plutonic igneous rocks are those rocks that are formed when molten rock that is below the earth, which we've just said is called magma, cools and solidifies without coming out on the surface. It's going to form plutonic igneous rocks. When this magma comes out on the surface, we call it lava. When the lava cools and solidifies, it's going to form volcanic igneous rocks. We can also call them extrusive igneous rocks. Or when the magma cools and solidifies below, we'll call that intrusive igneous rocks. During our mineral class, we learned a lot about the different rock forming minerals. This week we're going to have a first-hand experience on how these different minerals combine together to form the different rocks that we have. The non-ferromagnetic minerals, those are light in color. We're going to find those mostly in our granites. And the ferromagnetic minerals, those are dark in color, like biotite, pyroxenes, olivines. We'll find those in our basalts and the dark colored rocks. The learning outcomes for this unit are as follows. You'll be able, when you are done with the unit, you should be able to list and describe the three major components of magma, compare and contrast the four basic igneous rocks. We're looking at the basaltic rocks, the granitic, andesitic, and ultramafic. So the four basic igneous rocks are the basaltic, we also call them mafic, the granitic, we also call them felsic, and the andesitic, they're also called intermediate, and ultramafics. You identify and describe the six major igneous textures. You'll be able to distinguish among the common igneous rocks based on texture and mineral composition. you will be able to summarize the major processes that generate magma from a solid rock, and you'll be able to describe how magmatic differentiation can generate a magma body that has a mineralogical composition that is different from its parent magma. And lastly, you will be able to compare and contrast these intrusive igneous structures: dikes, silts, batholiths, stocks, and laccoliths. I am available to answer your questions. Text me, send an email, call my number if you have any difficulties or any challenges. We are also going to have an igneous rock lab component this week. And the lab is going to be straightforward, just like the mineral lab. You'll be expected to identify the samples that will be given and answer the few questions that will accompany it. Have a fantastic week. Thank you.